Energy transformation just describes when an object turns one form of energy into another. Your biggest obstacle in understanding energy transfers will be remembering the different types of energy. Chemical energy is found in anything we eat or burn. So petrol, diesel, coal, oil are all fuels we burn, so they all contain chemical energy. Chips, bananas are food, they contain chemical energy. Batteries also contain chemical energy. They may produce electrical energy, but inside them are chemicals, so they contain chemical energy. The roller coaster ride on your screen is responsible for turning gravitational potential energy into kinetic energy. Remember, kinetic energy is the energy anything has when it moves. It's just simply another name for movement energy. But gravitational energy, or gravitational potential energy, is a type of energy anything has if it is placed high up. Anything that is high has the potential to fall. So we say that anything high up has potential energy. In these three pictures, we can see the gas cooker above turning chemical energy in the gas into heat and light. We can see the candle also turning the chemical energy from the wax into heat and light. The woman in the picture is turning chemical energy in her muscles into movement energy as she pushes a box. In this picture, the woman has used the chemical energy in her muscles to pull back the bow, which has now stored that energy as elastic potential energy. Elastic energy. This can be found in springs as well as elastic bands and bows and arrows. When she lets go, the elastic potential energy will turn into kinetic energy as the arrow is fired. You may see some things like this in your lessons or on the exam paper. This is an energy transfer diagram. On the left-hand side, we simply write down the energy which goes into an object. In this case, petrol goes into the car, and petrol contains chemical energy. On the right-hand side, we write down all the forms of energy we get out from the car. We see we get kinetic energy, which is the movement of the car, sound energy, and heat energy. We know the engine warms up. If you put your hand on the bonnet, you can feel that. The size of the arrow represents the amount of energy, or the amount of each type of energy given off. So in this case, we will actually get more heat energy given off than kinetic energy. You might find that strange. You might think a car is built to move, not produce heat. But quite often, lots of energy is wasted in other forms. In this energy transfer, the sound and the heat are not what the car was designed to produce. They are classed as wasted energies. The kinetic energy is what the car was designed to produce. So we call that a useful energy. Finally, you may hear the word transducer. A transducer is not anything special or complicated. It is just anything which turns one form of energy into another. So this roller coaster is a transducer because it turns gravitational into kinetic. This bow and arrow is a transducer because it turns elastic potential into kinetic. And so on. Quite often, transducers that we learn about in class are things we plug in, which use electrical energy and turn electrical energy into other forms. You may be asked why electrical energy is so important. Well, this is because electrical energy can be turned into almost any type of energy we want. If we want to produce light, we can make light from electricity. If we want to make heat or sound, we can make those forms of energy from electricity. Movement, the same. We can make movement from electricity. So electrical energy is the only form of energy which has this versatility. That's why it's so important.